And hello everybody, you asked for more, and this is Mike and Oleg and the second part of addressing video. Yay! It's cool, addressing, message passing. We'll cover some advanced topics today, right?
Yeah, last time we looked at the basics of addressing, like how to address game objects and components, and what we're going to do today is to look at how that works in conjunction with factories, things that you spawn dynamically.
Factories, and also we'll see what happens when you need to talk from one collection to the objects in another collection.
Well, yeah. For example, if you can, there are two types of factories, and the simplest one is the normal factory that spawns a game object, and then we have a collection factory that spawns a hierarchy of game objects. So you need a way of addressing.
And we'll talk about worlds, game worlds, lots of cool things today.
We'll see if we get to game worlds. Otherwise, we probably do that in a separate.
Yes. Otherwise, you have to ask us again to cover this topic. So let's see, how do we talk to the objects created by factories, I guess.
Yeah. I'm thinking about, let's look at, this is the thing we did last time when we did addressing. Let's look at this little project. We have an astronaut and that was able to pick these gems up, and let's try to modify this into some game where you walk around and try to find gems instead. So let's start by removing the gems from the level collection. Let's find them. They are. So we should just drop these out of the game, and then what we should do now is to change the game so that instead of picking up gems, we should dig up gems. And a very simple implementation of that would be that I walk to a spot and then maybe press space and to simulate that I'm digging, and then we will spawn a gem at that position when I dig. So the first thing I need to do is to make sure that I have input for that action. So let's add a key trigger for it. Space is good, and let's call that dig. Space is good for digging. Yes. And then we go to let's do this with the astronaut script. So we have a couple of, this is where we get the input. So let's add one section here for the digging part. So let's, if the action that we get is called dig, then I'm just going to print it to begin with to make sure that we get this. Let's see. Yeah, we get it down here in
a bit of off topic, but then I see people asking for that on the forum. Why do we have to hash the strings?
Well, it's much more efficient to compare hash strings than doing a full string comparison.
Do we have to hash all the strings? Like if we're like when addressing, all the strings have to be hashed.
Yeah, they are.
When printing a screen on the screen, a string on the screen, do we hash it?
No, we don't.
Right.
There is another reason for hashing the strings in addresses, and that is because, well, it becomes very technical, but we can do addressing through a hierarchy by applying a hash onto a previous hash. So there's a very clever trick going on there in the ending, but let's not dig into
next
that.
time, unless you don't ask.
But you can just in Lua you can work with regular strings if you want to. That's fine. So it's just that the engine always sends hashed strings or hashes that you compare with. So
good.
Like
Clear.
Let's spawn a gem here. Oops, gem. And we do that by applying. There's a function that is called factory and create, and we send it a URL to, let's call this dig or a gem factory. So that's all we need to do in the code in order to create a new gem. But we need to this component doesn't exist yet, so we need to create that in the Astronaut game object. So let's add component here. We have the factory here, and it should be named gem factory. And we also need to tell the engine what type of game object this will spawn. So let's set the prototype to gem.go, which is the game object file for the gem.
The load dynamically checkbox.
No, we're not going to bother about that right now. So it wouldn't change anything if we check it or not running it like this. But there's difference in how the resource management works with dynamically loaded factories and others. So
cover it in next video.
Yeah, maybe. Yeah. So let's run this, and I can press space, and we spawn gems. You see, it looks funky because the gems has some code that makes them disappear. So let's fix that. We have the pickup thing still in here. So they try to figure out the position of the player, and then animate to that position, and then delete themselves. So let's say that.
But like for those who lost us already, so what happened is that Mika did a button that creates a gem using a method, like a component called factory.
Yeah.
The gem is a game object.
Yep.
That's the prototype that we linked to. We created it last time. See the video if you missed it. So that's what is happening. Basically, by click of a button, factory creates a gem.
Exactly.
And that's it.
So this code here is run each time I press the dig button that I set up in the input, and that is currently space. It's a little bit of a problem. You see that if I press it a long time, I can spawn like 1 billion gems, and then
that's a snake game.
Yeah.
And the gem factory here in create gem factory, that's like the address of the component that we created like a minute ago.
Yeah.
Hope it is clear.
So let's add that condition as well. So we just one at each press. So if I hold, there's still only one. So that's the first part of it. So we see that what happens here is that let's draw this. We have this is the astronaut, and it has a factory. Let's draw it like a small factory. That's a component, and that component has a
prototype. Yeah,
a prototype that is a gem file, and whenever we send a message to or call a function on and provide the address of this component to that function, the factory create, and we pass in the address of this guy here. Let's call it A here, and we say A here. This is becoming messy. What happens is that the engine will produce a game object based on this prototype. So this is what happens when we do this. So okay, we talked last time about addressing, and one thing that is guaranteed in the default is that everything that you create has a unique address, and that address stays the same. So for example, if you
and it's easy to see the address when you constructed some on the scene.
Yeah, exactly.
But now these games are created by the factory. So how do you figure out the address?
Yeah, exactly. So the astronaut, for example, it has an
astronaut ID
based on the ID here. So what happens is that we create something dynamically, or the engine creates something dynamically for us, and what is the address of that thing? And let's find out. So
print.
Yeah, let's store the address, because this function returns the address of the spawned game object. So let's store that in
game objects.
No, it's just one game object. Local geo address, and sorry, and then let's print it. Like that, and then let's run it and look in the console here and see. The first one is called instance 0, the second one is called instance 1, 2, 3, 4, 5, 6, and so forth. So the engine invents a name for each and every one of these. And it just goes on until Kingdom Come. So we can use these addresses if we want to and do stuff. For example, we could, let's add a little bit of, let's go into the gem script and make sure that we have a, let's call it else if message ID activate. And then what we're going to do here is we're going to change the gem game object a little bit, because what we do have is that a gem is, oh, where did it go? Oh, sorry, I just moved that for some reason. It should be there. The gem is made out of a couple of different animations. So let's go into the sprite atlas, and this is a gem, and playing it you will see that it animates nicely. And let's make a copy of this that is called gem idle, and remove a couple of frames. Sorry, oh, here we go. So the gem idle is, it doesn't do anything, it's just one frame of animation, so it doesn't do anything. And let's change the default animation to gem idle. There we go. So what we do have now is that nothing happens with these guys. So let's keep them there, and what we do now is we go back to the gem script and we say that okay, these are going to be activated, and activating them means that let's fire off a timer and do a delayed timer and say that after 1 second it's not going to repeat, and the callback is going to be a local function. Sorry. And in this function, when this fires, what we're going to do is we're going to do we're going to change the animation on the sprite. I think it's called sprite, but let's check in GemGeo. Yeah, it's called sprite. So we're going to do a send it a message that's called play animation, and it takes a couple of or an ID and again a hashed name, and it's going to be gem, I think it's called, right? Yeah. So this was going to happen when we send it the message activate. And going back to the script here, what we can do instead of printing that address, we can use that and send it this message. Message post, and we're going to send it to the geo address here, and we're going to send it activate, we call that, right? Reload that, and I think we need to reload this script as well. Yeah. So let's see if this works. Yeah, you see after 1 second it starts animating.
So you don't store the addresses of the created gems in a table, you just talk to each one as you create, and forget. Yeah, and forget. And for this purpose of just activating them, that's fine. In a real game, you probably want, there are many cases where you would want to remember the address of each game object, and in that case you would do something like, okay, let's say I have I have a table somewhere. Let's do it like this. I have self my gems and start out with an empty table, and then whenever I spawn a new table, maybe I do a table dot insert
gems, and then we store the address. So let's rerun this and for a while and just spawn a couple of those, and then let's print on reload here. Let's print that table to just see what we do have. Gems.
You're not fan of just putting a breakpoint and looking into what does the table?
Well, I can do that as well, but this is fast enough. And we see that, okay, currently I have 5 entries in the table. Each entry corresponds to the address of one of the gems. So there's 1, 2, 3, 4, 5 here. And now I can communicate with all of them, delete them or send messages or whatnot. One thing to remember here is that the position or the location of the astronaut does not really matter. I can illustrate that by doing a thing. We see that the astronaut is part of the root of the main collection. So let's remove the astronaut from there and put the astronaut in the level collection instead and run. It still works just as well. And some of you might think that what would happen now, because you saw that the names of all the ones we spawned was called like /instance 1 and so forth. So that was before. So what would name now be now when we are in the level collection? You might think that you would have something like this. But let's check. So if we reload the astronaut script here, we should see the table, and we see that the names are exactly the same. So this does not happen. And the reason for that is that the structure, the collection structure that you see here with level and astronaut, those are just names. So the collections does not exist in runtime. So those are just names, and these names are just arbitrary names. So they don't have a like a location in a hierarchy in runtime. It's just a naming thing.
Right. So everything under like the root collection, instead of like the tree structure as you see in the editor during the runtime, is just flat.
Yeah, it's just flat.
Okay.
So.
But what if you load a new collection via the proxy?
Yeah, that is an interesting thing. Let's. Oh, sorry, I'm in the wrong.
Because you must structure your level in a small chunks to save the memory.
Yep. So let's do that. Instead of spawning a gem GO, let's make a little bit of a structure. Let's call this gems. And let's add a couple of gems should add them from file. Game object file. Here's one, and let's copy this a couple of times. So we have, let's say, 3 gems. So now we have a little structure of game objects, 1, 2, 3. And in astronaut script, we should replace this with a gems factory, something that creates gems, a bunch of gems instead of one. So what we need to do here is to change this. It's not enough to just change the ID, because we need to use a different component. This component just spawns based on game object prototypes. So we need to add a component that's called a collection factory. So let's call that gems factory, and the prototype. Now we see that we don't we get the collection. So let's use the gems collection here. It works just like the other one, but it's based on collection instead of game objects.
So instead of loading a single game object, we load a set of them.
Yeah. So let's spawn bunch of gems. Right, so let's run this and see what happens. Press, oh sorry, component. Yes, component expected to be of type factory but was collection factory. That is because I forgot to change, because we can't use the same function either. We need to use a function that's called collection factory.create. Now it should work. There you go, 3 of them each time I press. Right, so all is well, but how the hell do I address those 3? Because what I get back in the previous case, I got an address back.
Let's print it.
Yeah, let's print it and see.
Can't wait. Can you wait?
Address. Let's print that.
Intrigue.
Oh, it's a table, you see? So we can't just, we should use the pprint to see the table. Let's run again and boom. Right, this was interesting. So what we do get here is a lookup table where on the left hand side you have a name, a hash name, gem1, and on the right hand side we have another name. So these names on the left hand side correspond to the names that we have given the gems in the collection. You see, gem 1 and 2.
Yes, named gems.
Yeah, exactly. But the engine needs to create a dynamic name, and those dynamic names are the ones that are on the right hand side. So we can use this to look up a particular gem. For example, if we want to, let's say that whenever we spawn 3, we want to remove one of them. It's a silly example, but let's try to build that.
We can change animation, so it's not that silly.
Yeah, exactly. So let's call this gems instead, to be a little bit more. So, and what we can do here is to let's do a local gem2. That's going to be gems, and we need to look up the one that corresponds. It's gem2. It's that one, that entry. And let's write
hash again.
gem2, and that is, we do a lookup in the table, and let's print that. We see that it's called collection 0, gem1, collection 1, gem1. So each time we spawn a new bunch of game objects, they are named collection and then a running number. And then gem2 is the
gem we're talking to.
Yeah. So this is just a name again. And now we can use that to, for example, let's start animating them. Message post gem2, and then do activate.
Remember that activation function that we added?
Yeah, and let's see.
It started. Yeah. It works.
It works.
Spawn a new one.
Yeah.
And yes.
Yeah.
All good. Only gem2 gets animation.
Yeah. So again, it's important to understand that the names that we get back are just names. It just happens to be collection 0, 1, 2, 3, 4, but it could just as well be like banana 1, 2, 3, or just a random piece of string. But it's nice for debugging purposes that it's called what it's called, because we know what we're dealing with. So, but those names are totally arbitrary, but they have to be unique in the runtime.
This all makes sense to me. Do we still have time for the collection proxy? And the correct answer is no. We don't have time for collection proxies, because that would add another 20 minutes.
At least, I think.
And our YouTube stats say that you, my dear viewers, cannot take more than 20 minutes in a single sit. So we'll do a next video about collection proxies and how to address objects there. We'll speak about sockets. But today we'll answer user questions. The one that came to mind now is the following. So a user in one of the chat asks, what is the speed of the messages? Can they use messages for fast pacing events, such as when a bullet hits something, or like when you want the action instantly or immediately?
Oh yes, actually the engine uses messages to handle things like collisions. For example, we see that here. This is the collision between the astronaut and things in the level, and the physics engine sends messages to the script so it can respond quickly, and that happens each frame. So you can respond during the same frame.
So something happened during frame number 1, and the message gets delivered during the frame number 1 or frame number 2?
Frame number 1.
Okay, so the messages are expected to be delivered, like you send the message
at the end of the. If you do something in the update loop, it will arrive at the same frame to the targets at the end of the frame.
That's a good answer.
Yeah.
Can the message pipeline be clogged?
Well, what happens is that let's say, for example, that you have someone that sends a message to another game object, and that game object in turn adds new messages to the message queue. The engine has a message queue, and it runs through that message queue a number of times each frame. So it runs through one time, and that might result in new messages being added to the queue. And I think it runs through it like 16 or 17 times or something like that. So you can have really long chains of messages. So you will not exhaust that. And there is no limit really to how many messages you can have during one frame. The only thing that will happen if you have too many messages at a single frame is that you will have a hitch. Messages are not for free. There is a little bit of overhead with them, but so you should not use them like as getters and setters in object-oriented programming. You should use them for higher level actions and so forth. Like, for example, taking a hit from a bullet or changing state of something or whatnot.
I'm just thinking
but don't use it to pass lots of data around.
Right. So how do you pass data then?
Well, the best answer is to try to avoid passing data as much as possible.
No, actually that's a very good tip.
Yeah. And if you need to pass data, try to make it as small portions of data as possible. Sometimes you need to pass data. For example, if you have a saving system, you might do that through. It depends. Well, there's a limit to how much data you can pass in a message. So if you exceed that, you need to store it. You need to store it in a module, a Lua module, for example, and pass a reference to that through a function call or something. There are various ways you can.
Yeah, makes sense to me. Any other performance advices on the messages?
Yeah, try not to send like hundreds and thousands of messages each frame. That is pretty much the best advice. Try to limit the number of messages, but that is like do as little as possible all the time. The fastest code is code that never runs or doesn't exist even. So that's always good.
We're going esoterical, and let's just stop it this time.
Yeah.
Record. So Mickey, people actually like what we're doing. They like our videos. They ask for more. So we should record more.